Good morning, everyone. This is Karpuswamy Sulamuthu, Department of Civil Engineering, SR Ministry of Science and Technology. Today topic is adversarial search method. This is a searching algorithm used in multi-environment agent, where the agent having conflicting goals. So far, what we discussed is in the traditional approach, it is always trying to reach the goal, whereas in the case of adversarial search method, it is considering the opponent move also. Based on that, it is designing their moves. So it is used more effectively in the game development, AA game development, and in which it is very effective for various reasons. And when you talk about the type of algorithm, there are minimax algorithm, and there is an alpha beta pruning and expectimax algorithm. These are some of the examples for how the adversarial types are belongs to. When you talk about minimax algorithm, from the name itself, you can say that the agent is trying to maximize the score, whereas minimax, I mean the opponent, it is trying to minimize the agent scores. So that is called minimax algorithm. And alpha beta pruning, it is optimization of minimax algorithm, I would say. And in addition to that, this is reducing the time complexity, because any unnecessary branches are there. In that case, you can remove the unnecessary branches without affecting the results. So that is a main aspect of alpha beta pruning. Expectimax algorithm, you can see the whole entire tree. Expectimax algorithm consent. These are some of the example for example, tic tac toe, but it is not deterministic. Of course, it is random. Where the random game is there, where the random agent is involved, in that case, we go with what you call expectimax algorithm. And when you talk about the characteristics of adversarial search method, it is more deterministic. And it is not a random deterministic one, multi-agent. So and perfect information, that means that we can see the entirety of this the whole system. And these are some of the characteristics as per the adversarial search method concerned. Let me explain with a simple diagram here. So there are player 1 and player 2. Player 1 is the maximum agent, and the player 2 are the opponent, I would say opponent. If you look at that, player 1 consists of 3, that is a root node, which consists of A, B, C, and action A, B, C. If you take the action A, player 2, that is a minimax, which consists of again A, B, C. If you look at the value -4, 5, -3, here it is taking the minimum values. If you're taking that as an example, in which -4, 5, -3, -4 is the minimum value. So action A, player 2 have -4 as a minimum value. If you take action B again, there are three values, 6, 2, -9, in which -9 is the lowest value. So it is taken as a the further levels, so -9. And action C, you have -7. So if you look at the other level, we have -4 from action A, -9 from action B, and -7 from action C. Now you suppose take the maximum value of that, in which -4, -9, -7, -4 is the maximum value. So what we can understand from here, minimax algorithm. So this is an example for minimax algorithm. One value is trying to minimize the values, other part maximize the values. So the second part, the player 1, that is a root node, that when it comes into the maximizing, it is selecting the highest node. So with considering that, how the minimax algorithm is working out, it is used more effectively in the board games and chess and tic-tac-toe. It is always, as per the tic-tac-toe concern, the opponent, the the agents try to win, but maximize the score, whereas the what do you call the opponents try to minimize their score. So, considering that adversarial search method, it is more effective, especially for control strategies, strategies for developing the game. Then, in that case, it is more useful as far as adversarial search method concerned. Thank you.